In this video we show a new system which can create a dense reconstruction of objects and indoor scenes in real time. The only sensor in our system is a low-cost depth camera which is moved around the environment to be reconstructed. As this happens, the system builds and continuously refines a dense map, whilst simultaneously tracking the 6th DOF position of the sensor. Here the dense model is rendered using Phong shading, and a normal map is shown alongside. A wireframe of the frustum of the mobile KINECT camera is also displayed. A relatively detailed model of an entire room can be generated quickly and easily. Here, the view from the KINECT device is shown at the top of the video, and the corresponding dense model is below. The coverage and fidelity of the model is continually being enhanced. If objects in the scene are moved, the model quickly adapts. When this box is added, the front faces appear almost immediately. Additional detail is filled in as data becomes available. A model which incorporates the detail of facial expressions and clothing is generated remarkably quickly and easily. Using data from the RGB camera, it is possible to texture map the rendered model to create a photorealistic look. Colours in the scene are refined over time as more data is collected. As these examples show, we get geometrically accurate occlusion handling. Here, a virtual shiny metallic sphere is added to the scene. We can also add artificial diffuse and specular lighting to the scene in real time. Virtual objects can interact with the dense model in lifelike physics-based scenarios. Here, we show the particles which are used to approximate the surfaces in the scene to enable real-time physics simulation on the GPU. We support interactions with dynamic scenes by deforming the relevant surfaces and any associated physics particles in real time. Movement of the KINECT camera relative to the rest of the scene is continually tracked. Objects moving in the scene, even relatively large ones such as hands and arms, do not impact the tracking too adversely. In fact, we are able to build up and constantly refine a model of a tracked foreground object. By changing the reconstruction parameters, we can model fast-moving foreground objects while still refining the static background. In fact, such movements can be used to detect touch interactions with objects in the scene. Here we demonstrate this property with a simple augmented reality 3D paint application. When the KINECT camera viewpoint is altered, the accurate registration of the paint with the scene is clearly apparent. In another interesting scenario, the system can be used with a fixed KINECT camera and a moving object. Here, a model of a human torso is being 3D scanned. Objects which move in and out of a scene can be readily segmented by querying the dense model for changes. Once segmented, the object can be tracked independently, using the same technique that's used to track a moving camera. We demonstrate tracking here by re-registering the segmented object with the real-world object. Here, we track the movement of two depth cameras simultaneously to build up a single, high-resolution model of the environment in real time. Each camera tracks independently from a sparse model and contributes to a shared volume once correspondence between the two cameras has been found.